Hi, Julian.
Hi there, how are you?
Good, thanks. How are you?
I'm okay, thank you. It's a very strange time. Go on.
Hi, Alecos.
How are you?
Good, thank you. How are you?
Fine, fine.
Oh dear. Do you know what? We chose a really bad day to do this. It's Black Friday, and the bandwidth for everything is just non-existent. Alecos, you're just going nowhere on this one, I'm afraid.
Person yet.
It is Alecos bandwidth and not mine, isn't it?
Yeah, no, I can't hear anything. I can hear you, Julian, but
okay.
I think, really struggling with Alecos's connection. I don't know if you try stopping your video, Alecos, it might improve.
Okay. Oh.
I think we can hear you. No, maybe not.
No.
If it's a problem, change
I heard if there's a problem, and then we lost you again, I'm afraid.
Just me. Hello.
Hi.
Hello, everyone.
Hi, Keith.
Hi, Keith. We're just hoping we can actually get Alecos on this one. It's fairly imperative.
Hello.
Hi, Alecos. Do you want to try sharing your screen and we'll see if we can actually get a...
Okay. Minute. Share screen. Problem is, can you hear me? Hello.
We're really struggling to get your connection, Alecos. It's not shared the screen on my display yet, and really struggling to hear you.
Oh, it's the football as well, isn't it? So between football and Black Friday, we don't stand a chance here.
Switch for a second.
I think that might have kicked him out of the
Zoom.
Let's see if he can rejoin, unless Zoom kicks him out.
For those of you who are trying to join us, please bear with us. We're just struggling to try to get our speaker online. We will keep going for as long as we can reasonably keep going. I would say chat amongst yourselves for a wee while, but that actually makes it quite difficult for a bit.
So it seems that Alex's internet is slow.
I think so. It's not just so much slow, it's just not working at all.
He's back. See if
Okay,
it's
we
any
get
better.
Alex here now.
Hello, can you hear me?
Oh, that's a bit
Yes.
better.
Hello.
Yes, Alex, we can hear
Alex,
you.
we can hear you now.
We can hear him, he can't hear us.
Hello, hello.
Yes.
Alecos, we hear you. We hear you. You can't
Okay.
hear us.
You
Alex
can hear
cannot
me.
hear us.
Okay, that's good.
Oh.
Right.
That's more like.
Share screen. Okay,
Yes.
Yes.
we are on. Sort of, anyway.
Do you want to work with it like that, or do you want to bring it up properly?
Yes, I'll bring it up probably just a minute. I'll switch off a few
Okay.
things that we don't need.
Okay.
Okay, is it better?
It
Yes,
hasn't
that's much
changed.
better.
The sound's infinitely better, but the slides haven't moved.
There we go.
There we go. I suspect what's actually going to happen, Alecos, is that there'll be a delay between the slides coming up and
Most likely.
you talking to them. So as you move on, it might be a wee bit on the slow side. Are you comfortable with that? Are you happy to go?
Yes, I'm happy whenever you want. Yeah.
Right, okay, that's fine, in which case I'll get rid of my video, and that's a bit less. So welcome this afternoon, and on a beautiful Friday afternoon, to everybody who's joined us for yet another of our fellows talks. Today we have Alecos Demetriades. Thank you very much indeed for offering to do this for us. The talk this afternoon will be about work which the International Union of Geological Sciences have been doing about establishing a manual standard methods for establishing the geochemical reference network at a global level. So enough of my gruff voice. I will hand over to Alecos and hope that everything holds together for the rest of the afternoon. Thank you, Alecos.
Thank you very much, Gillian. And I'm very pleased to participate in this SEC fellow seminars. And I hope we have better attendees this time. Right, let's start. Well, I'm following Xiandong Li's sort of way of starting. I have started from Cyprus way back in 1962 and left Cyprus, my hometown Larnaca, with the Notria, the ship, and reached in July 1962 Coventry. And from there, I went to Parkes Secondary School, and I had a very good teacher, Mr. Ashworth. And afterwards, I started my GCE ordinary levels at Coventry Technical College, and I had very good lecturers, Mr. Edwards and Mr. Alex Chater, and also Henley College of Further Education. Then I decided to follow geology. So for a whole year, 1966, 1967, I did not do anything else but studying geology at public grammar school and also at the University of Birmingham Extramural Department in Coventry. Then I followed another course in Nuneaton Technical College for GCE ordinary levels, with geology included again, and returned to Coventry Technical College for my GCE advanced levels before going to university. I studied at the University of London, Queen Mary College and Birkbeck College to 1972, 74, sorry. And the person that influenced me greatly was Paul Henderson, who is a very good geochemist. And also I have followed lectures with Professor John Webb. And then I went to University of Leicester for MSc Mining, Geology and Mineral Exploration. And there I had a very good teacher, Clifford James. And finally, well, during my retirement, in fact, at the age of 70, I completed my PhD in applied geochemistry at the University of Patras School of Natural Sciences, the Department of Geology, under Professor Sotiris Varnavas. Well, why did I do my PhD at such a late age? Well, as a professional geochemist, I was not interested to follow an academic career. I was totally devoted to my work at the Hellenic Geological Survey, and the work was so interested that I was not really interested in getting a PhD, and I was more interested in professional titles and followed the continual professional development program of the Geological Society of London, the European Federation of Geologists, and the Institute of Materials, Minerals and Mining for the professional titles of Chartered Geologist, Chartered Scientist, European Geologist, Chartered Engineer. But as I was registered for the PhD from 2002, and in order to satisfy my friend and Professor Sotiris Varnavas, I finally submitted my PhD at such a late age. Well, I do not recommend the younger to follow this sort of career with respect to PhD. Because times have changed, and most likely you will be needing your PhD for your work. I worked at Rio Tinto Finance and Exploration Limited as a researcher in the development of a global mineral deposit inventory, and I was coached by Mr. Keith Greenleafs, who used to be a very good mineral explorationist. And also afterwards worked at the Hellenic Institute of Geology and Mineral Exploration as an applied geochemist at the branch of the Eastern Macedonia and Thrace, and afterwards at the Central Division of Geochemistry. And I left the institute in 2011, following a 3-year being the director of the division. Now, since my retirement in 2011, I've been very busy with the work of the Eurogeoservice Geochemistry Expert Group and also the IUGS Task Group, and since 2016, the Commission on Global Geochemical Baselines. Now, during my professional career, the 4 people that influenced me greatly was Arthur Smith, Aisling Arma-Brown, Professor Jerry Govett, and also Professor Bjorn Borviken. Now, from 1976 of my career as an applied geochemist until 2022, after 46 years, apart from internal ICME project and contract reports and European Commission co-finance project reports, I have actively participated in the writing and editing of 3 European project reports, 3 geochemical atlases, 1 textbook on urban geochemistry, 6 mapping manuals, 3 quality control reports, 3 special issues of the Journal of Geochemical Exploration, and over 100 peer-reviewed papers published. Now, 3 books that may be of interest to SEC members is the Mapping the Chemical Environment of Urban Areas and the 2 manuals for urban geochemistry. Now, what are the elements to achieve success in your work? And hopefully a lot of young researchers are listening to me. You need 9 elements: perseverance, patience, determination, self-improvement, teamwork, enthusiasm for your work, positive thinking, passion, and balance between your work and the home environment. This is very important, something I did not keep. If one of these elements is missing, then you must think if this profession is right for you. Now, Michael Faraday, regarding how to sort of promote your work, he said you have to have three elements: work, finish, publish. Now, this was said in the 19th century when there were not many publications. Today, you have to add another action at the end. It should be work, finish, publish, and promote your work. Now, I like a quotation from Jules Henry Poincaré. I'm sorry for my French. Science is built up with facts as a house is with stones, but a collection of facts is no more a science than a heap of stones is a house. It's for you to think about what you do with your data. And I will end up this, let's say, short philosophical opening with another quotation by Michael Faraday. Nothing is too wonderful to be true if it be consistent with the laws of nature. There is nothing quite as frightening as someone who knows he is right. It is right that we should stand up by on our principles, right to hold them in obstinate lightness or retain them and prove to be erroneous. So the only way of rationalism is wrong. Okay.
Alecos, we have a bit of a problem here. You're bouncing around with the sound and we seem to have lost you completely at the minute. Alecos, can you hear us? Alecos, we've lost you. There's nothing changing on the screen. Olivier, have we lost him completely? Has he disappeared off the system?
Yeah, it appears that we've lost Alecos from the Zoom. If we maybe give him another chance to rejoin.
Absolutely.
So if everyone could just please bear with us whilst we're having mild technical difficulties.
I think that's an understatement for the moment, isn't it? But these things happen.
Hello?
Hello.
Hello.
Yeah, we can hear you.
No, let me see now how I have to sort of get it up again.
Yeah.
No, you cannot see it probably.
Not
No.
at the minute.
No. Just a minute.
You need to go and sit on the roof, Alecos.
Just a minute. Share screen. Can you see the screen?
Yes.
Okay. Is it okay?
Yes.
Right. Let's keep our fingers crossed.
Okay, thank you.
Right. And now, regarding the concept of a global geochemical map, the first idea came in 1984 at a conference of the International Atomic Energy Agency in Sweden. And of course, as they were interested in radioactivity, it was about making a global geochemical, a global radiometric map using ground and airborne scintillometry for potassium, uranium, and thorium. Of course, it was recognized that they needed to add other elements. Now, what was the incident that shocked the world with a possible global disaster? This is the incident, the Chernobyl accident in Ukraine on the 26th of April, 1986. This catalyzed interest in global scale geochemistry. And in fact, it was the first time that we realized that we did not have the baseline to assess the damage done in the European environment. However, is the only anthropogenic induced hazard that humanity is facing? We are now in a new destructive era, the Anthropocene, which was discussed also by Darnley in his sex seminar. Humans, ever since their appearance on Earth, have been modifying the natural environment in order to improve their living and working conditions. So we are now in a new geological era, the Anthropocene, characterized by humanity's extensive destructive impact on the Earth's landscapes. And according to Margaret Atwood, it's not climate change, it's everything change. These anthropogenic-induced environmental changes affect the quality of the air we breathe, the water we drink, and the soil in which we grow our food. In fact, they affect our exposure to infectious diseases and even the habitability of the places where we live, work, and play. The Anthropocene defines Earth's most recent geological time period as being human influence or anthropogenic, based on overwhelming global evidence that atmospheric, geological, hydrological, biospherical, and other Earth systems processes are now altered by humans. Here we see the Anthropocene Atlas. Green indicates the least modified areas, which are not populated, in fact, and the red, the most, and these are the most populated areas in the world. Here again, we see the Forest Integrity Index in 2019, and again, is where you don't have population, we have greatest forest landscape. Here we see forests taken over by agriculture, mining operations, industrial operations, and of course, the greatest hazard, the urbanization. And rubbish. We have a lot of rubbish all over the world that we don't know what to do with them. And of course, the Anthropocene and all the emerging contaminants are on these slides. So soil, sediment, and water are the most valuable natural resources for our quality of life, and we need to know their chemical composition. So how can we study the changes? Geochemical mapping provides the tools of visualizing the spatial variation and intensity of the human-induced threats. The question is, what sort of global geochemical baseline mapping do we need? We don't need just any global geochemical database. Darnley et al. Justified the need of a harmonized global geochemical database with the following timeless statements. Everything in and on the Earth, mineral, animal, and vegetable, is made from naturally occurring chemical elements. The existence, quality, and survival of life depends upon the availability of elements in the correct proportions and combinations. And here we see a graph with the blood concentrations, the human blood concentrations, and also the concentrations of elements in the upper continental crust. So you see that there is a very nice correlation between the two. So it proves that we are closely related to our Earth systems. Mary Lou Zopak, in her 2000 presidential address, stated, "Documenting and understanding natural variability is a vexing topic in almost every environmental problem. And how do we recognize and understand changes in natural systems if we do not understand the range of baseline levels?" And here we see a map of Europe in the top left-hand corner and different sections. And you can see that there is a variable geochemical baseline depending on which section you are looking at. And here the one from the fourth one, if you take from the Alps, to Ukraine, we have a sort of gradient. So essentially, we have a variable geochemical baseline in Europe and, of course, all over the world. Now, what continental scale geochemical surveys are presently available? We have the United States, the Chinese, and also the Australian geochemical mapping projects. And also there are ongoing national geochemical projects in Mexico, Colombia, Peru, Argentina, and many other countries. Now, the only geochemical harmonized geochemical surveys that we have are in Europe, the Forex Geochemical Atlas of Europe, and also the GEMAS Geochemical Atlas of Agriculture and Grazing Land Soil. Question: are geochemical data interoperable at the national and international scales? Definitely not, because of lack of standardized sampling, sample preparation, quality control, and analytical protocols. All this make it difficult to impossible to match the existing geochemical datasets. How can standardization and harmonization of geochemical data be achieved at the national and international level? The answer to the second question is given in the Blue Book and the recently published International Union of Geological Sciences Manual of Standard Methods for Establishing the Global Geochemical Reference Network for the production of internally consistent quality control global geochemical datasets for multipurpose use. These are the two books, and both of them, they stress standardized procedures must be used. Randomized sampling, samples collected by the same procedure using the same equipment, samples prepared in the same laboratory, and samples analyzed in the same laboratory with the same analytical method or methods. At all stages, a strict quality control procedure must be installed. All standardized procedures are described in the manual that this is the subject of this webinar. Now, the IUGS approved this publication as a formal publication for its 60th anniversary celebration, which is this year. And we thank the Executive Committee for this honor. The contents of the manual is we have a general introduction, and also discuss how the global terrestrial network crystals are made, the selection of sample sites and samples to be collected, the sampling methods. We have rock, residual soil, humus, stream water, stream sediments, overbank and floodplain sediments. Then we have the sample preparation and storage, development of reference materials for external quality control, geoanalytical methods and requirements, quality control procedures, data conditioning methods, generating time-independent geochemical data, data management and map production, project management, the field observation sheets, and also we have geodetic leveling of existing chemical datasets and parametric leveling of existing geochemical datasets. Question 3, how is the global scale geochemical sampling campaign planned? The starting point is the global reference network, which consists of 19,833 cells of 160 by 160 kilometers. It consists of the global terrestrial network and the global marine network. And here you can see the cells, the global reference network all together. Now, in our case, the starting point is the global terrestrial network, which covers the land surface with 7,356 grid cells of 160 by 160 kilometers. Now, how do we do the sampling? It's completely randomized. We have the grid cell of 160 by 160. We have 4 quadrants, and in each quadrant there is a completely random point, and in one of the quadrants there is a second random point, and each of the random points represents one catchment basin. Now, for people that do not know the stellar system, here we can see it, the stream order. We have the first order stream. Again, I'm stressing this is done on a mapping scale of 1 to 50,000. We have two first order streams. When they join, they form a second order stream. When we have two second order streams joining, we have a third order stream, and so on. And here you can see a block diagram with the sites of for sampling. Now, how do we generate the random points? There is an accompanying book with R scripts for the generation of 5, 8, and 16 random sampling points within predefined rectangles. And you can run this in order to have the random points in any size rectangle. And for our case, we use 5 sides because this is the system that we have used in the Forex geochemical mapping of Europe, and it is cost effective and also produces quite good results, and cost effective as well. Here you can see a Google map of the Democratic Republic of Congo with the 5 random points in each 160 by 160 kilometer cell. And of course, if you are planning the geochemical baseline mapping in your country and you want to use a different cell size, you can do so, as I can show you here, because you can enter the scripts with any grid cell dimension you want. Now, the fourth question, which procedures should be followed for the production of internally consistent, quality controlled global geochemical databases for multi-purpose use? The key is standardization of all procedures from sampling, sample preparation to analytical methods and installation of a strict quality control procedure at all stages. Now, this is a key slide. I'm stressing 2 points, sampling and sample preparation. These are the 2 most crucial stages of any geochemical survey. Any errors during these 2 stages is carried forward and can result in the failure of the whole survey. So these 2 stages must be carried out by very well-trained personnel. Laboratories, yes, this is also important, but errors can be corrected by reanalysis of samples provided enough sample material is available. We have standardized detailed instructions are given for sampling, rock, residual soil and humus, stream water, stream sediment, overbank and floodplain sediment. And all the chapters are very well illustrated, as you will see when you study the manual. From the 5 randomly selected catchment basins of each 160 by 160 kilometer cell, representative samples of rock, residual soil, humus, stream water, stream sediment, and overbank sediment are collected from the second order catchment basin, and the floodplain sediment, top and bottom, is collected from the third order catchment basin. And here we can see one grid cell with the random points. Let's consider this point number 3. Oops. And here we have the catchment basin. And as I stressed earlier, you select the second order catchment basin. This is very important because it should be representative. And you collect from there the representative rock samples, residual soil, and if there is humus, you collect this humus as well. And the residual soil you collect from defined horizons, the A and C horizon, and you never mix horizons. And from the second order stream, you collect also the stream water, stream sediment, and overbank sediment. And from the third order stream, you collect the floodplain sediment side sample. This is the coding. of the sample. And also detailed instructions are given for sample preparation. We have rock sampling, residual soil sample, stream sediment samples, overpipe sediment samples, floodplain sediment samples. And as you see, always we have the field duplicate samples split into two for the quality control. Here we see it again in a larger diagram. And we have homogenization and splitting into subsample of all sample types. For the analysis, we have 10 subsamples of 100 ml each. And for the storage, for permanent storage and safe storage, I stress, we have recommend 5 samples of 200 ml each. And this is the storage. We had the Forex geochemical samples in Slovakia. Now they are all at the British Geological Survey. And here is how we organize the analysis. We have the duplicate samples, the reference samples, and the blanks. And in each rectangle here, we have all the other samples. And you can see here is a random order. And if you place it in order, then you can see that everything is randomized. And this is the way we analyze the samples. Now, all samples of each medium must be analyzed by the same analytical method at the same laboratory, and if possible, within a short time period. If the project runs for a long time, then other conditions must be followed by using the project reference samples to level the data. Methods of data conditioning for producing seamless geochemical maps are described in chapter 8. Now here we have the list of elements. We have list 1 elements and list 2 elements. Of course, they are all important, but it depends on the cost. Very important is checking of analytical data. Detailed instructions are given of how to conduct a thorough check of the received analytical data, and in case of errors, the particular batches should be reanalyzed, and in the worst case scenario, it may be necessary to demand the reanalysis of the whole sample suite. This is in chapter 7, everything's described. And always you have to produce a quality control report for all your analytical data sets. And if any problems are encountered and you find solutions, this must be clearly mentioned in the quality control report. Here we see a standard, and there is a spurious sample here. So this has to be checked, this batch, why we have this. And we stress that you should ask the laboratory to give you the results as they come out of the machine, the uncensored data, in order to produce your practical detection limits for each element, for each analytical method used. Here we have the balanced ANOVA design, and this is the result. That we have the analysis on variance, where we have the analytical, sampling, and geochemical, and these are the limits as defined by Ramsey. Now, if you don't do it properly, you come to this. You see here, straight edges. Yeah. These are map-shaped boundaries. And unfortunately, there were no randomization of the analysis. The samples were analyzed per map sheet, and we have this problem. And unfortunately, this problem is carried forward to the most recent compilation in 2020. You can still see the straight boundaries. So one has to be very careful of how to analyze your data, and also the quality control that must be installed from the beginning. This is the quality control in chapter 8, and also data conditioning. We have here the UK. As you can see, we have a completely different analytical data set for Northern Scotland and the rest of Scotland and Northern England. And because everything was done with good quality control, they were able, our colleagues in the British Geological Survey, to level the data to produce a seamless geochemical map of Scotland and Northern England. There are chapters for data management and maps, statistics. Here we see something that is not used any longer, a cumulative frequency curve and the breaks, where we used to have the populations. It's a good way to use again. The box plots are very good for comparing different sample data sets. As you can see here, this is the topsoil, subsoil, humus, stream water, stream sediment, and floodplain sediment from the Forest Geochemical Atlas of Europe. A good way of presenting the statistics of each element is to have a histogram, a cumulative frequency curve, a scattergram, and also a box plot. So you have everything in one image. And the recommendation is that you never start plotting color surface maps until you understand the distribution of your analytical data by plotting variable size dots in order to see exactly the patterns where they actually occur. And when you understand the distribution of your analytical data, then you can plot the color surface maps. But again, you should always plot on the color surface maps the variable size dots which show the actual concentrations of each element. And of course, nowadays, you can use the compositional data analysis, which shows a different picture. And again, you need both pictures in order to both maps, so in order to explain the spatial distributions. And from the as we have Google Earth, is another good way is to plot your variable size dots on the Google Earth in order to see exactly where you have the high and low and intermediate compositions. Now, something that we have for the Forex is that at each sample site, we always take at least 2 photographs, one showing the landscape photograph and the other the actual site conditions, and this can be displayed on Google Earth. Now, as you may appreciate, it's impossible in one lecture to present in detail the 550 pages of the manual. Therefore, I urge you to download it and study it at your leisure. And we are certain that you will find something that will help you in your work. And if you have any question, you can contact me or any of the other co-authors. All the chapters describing the procedure of sampling rock, residual soil, humus, stream water, stream sediment, overbank sediment, and floodplain sediment start with an introduction, required equipment, cautions where necessary, and the sampling procedure is well illustrated. As sampling of residual soil is the most difficult, the next few slides will show you an overall view. Now, this is the chapter. As you can see, there are many co-authors. We have the soil scientists involved in this as well, and they were very helpful in understanding what we should do during the sampling procedure. Now, as you may know, the soils vary with climate, and from the northern pole to the equator, we can see that there are different types of soil, but also we have different types of soil when we have a mountain area. We start from the low to the higher zones, and as you can see, there are different types of soil depending on the height of the mountainous area. Now, how we start with we go to a sample site. This is one soil sampling site, and the first photograph we take is the sample number. We take the general photograph as the surface photograph, and then we take a photograph of the pit. We dig, and also we see here a close-up with natural light and also with fill-in light, flashlight. And at the end, we always take a final photograph to show that we return the landscape to its original form. We put on, fill in with the soil again. And on top of it, we have the sample number and the 2 bags and the GPS, just to prove that we have put everything back in order. Now the sampling procedure, when we reach the sampling site, we switch on the GPS, or if you have a computer, you can switch on your computer GPS. And if you have problems, you have to move it to a open space in order to get the GPS coordinates. You write the sample numbers with black pen, and also on a small card you write the sample number at the front and the back, and you place it in a small Ziploc bag. Again, and you dig your pit. Yeah, we see. You mark your horizons. You start the bottom sampling first, and this is the soil C horizon. And when the sample is filled, you put on the small card, you put it in your bag, and then you close it, and you seal it, and also you, for safety precautions, you place it in a plastic bag for transportation to the laboratory. And the same thing you do for the topsoil sampling, the A horizon. And also at each side you take a radiometric reading, potassium, thorium, uranium, and also total. And most importantly, before you leave, you record all the field observations on a field observation sheet. And for humus sampling, these are the bags again. This is the instrument we use for the humus sampling. And because most of us are not familiar with all the different types of soils, we have the harmonized soil database, which you can have access here. There are 28 units in total. We have examples. All these are explained in the annex of the chapter. And for each soil mapping unit, as it's called, there is a representative photograph and also a description, and also the geochemical processes. And this is a very good sort of atlas, you may say, soil atlas for everybody to use. And we have a map showing the distribution of the recursos in this case, and the intensity of the color, as you can see it here, is variable. The greater the intensity it means that there you have definitely a aerosol, and as the shade is getting lighter and lighter, the share of that particular soil mapping unit is less and less. We have a Chernozem. Okay, this is very important soil, and this is where we are afraid with respect to the war we have now in Ukraine, because the war is on this type of soil. And here we see the distribution of Chernozems, and here we are in this area. And also we have KML files which you can plot on Google Earth, and you can also plot your sampling sites in order to see where your sample is exactly, and you can enlarge it. Here you can see it much larger. And also we have representative soil profiles well described in order for people to understand how the different horizons. Now this is very important. We collect residual soil and not transported soil. Okay, this is transported soil. This is the area that we collect the samples from. Now, very important, the sampling teams must be well trained by a soil scientist to recognize the humus A, B, and C horizons, and the naming of the soil type to be left for the experts. However, an idea, as I already indicated, is possible by plotting the KML files on Google Earth and seeing where your sample is exactly. Now, these are the profiles. As you can see, they are described, and we have used the terminology of the soil scientists. And what we are interested in is the A horizon and also the C horizon. Here we have a arenosol, a calcisol, a mountain soil, terra rosa, a luvisol, a cambisol, a desert soil, and skeletal ozone soil, which is not very good for sampling. You can download the manual, as I've already said, and also the following chapters have useful supplementary material, which you can download. And finally, an ebook that may be of interest to all of you, which is related to Mike Ramsey's webinar, Measurement Uncertainty Arising from Sampling. You can download this as well in order to estimate the balanced, classical, and robust analysis of variance, and also other measurement necessity as well. Now, final conclusion, this manual presents for the first time a comprehensive overview of the standardized methods that should be employed across the land surface of the Earth to map the distribution of chemical elements in rock, soil, sediment, and water. Now, what is needed is a robust project management structure that is independent of the interest of an individual, nation, or organization. Okay, thank you.
Alecos, thank you very much indeed. Let's see if we can get you up with your video. If you stop sharing your screen and we just go back to a normal screen there, and yes, hopefully we can start asking some questions of you. That was a really interesting talk. Thank you very much indeed. I really enjoyed that. It actually takes me back quite a long way to when we started to standardize health issues of trying to get people to evaluate things in exactly the same way. And I completely appreciate your move to standardization in that particular way. Can I see any hands up, please, for people who would like to start to ask questions? Let me see if I can. Keith, go ahead, please.
Yeah, hello. Hopefully you can hear me okay.
Yeah,
I can hear you.
Yes.
I'm sorry about the poor reception, but
Not at all. Thanks for that talk. It was very illuminating. My question relates to historical data. You showed an example from Alaska, and a lot of the issues in Alaska is the fact that the sampling was done maybe 40 years ago, where the detection limits of the equipment was much poorer than it is today.
yeah.
And obviously some of these areas are very difficult to access and resample. So my question is, what is your advice for incorporating historical data that's maybe of poorer quality, or should it just be disregarded?
Well, what we are trying to do is if they, we have, in fact, we have some examples in the manual where we have used past surveys that were carried out in the 80s. Okay. Now, the philosophy of the global terrestrial network is to have a network of standard, let's say, analysis. Okay. And each point, you may think of it as a triangulation point, similar to the surveyors. They use for topography. And I mean, if you have done surveying, you use the triangulation sites to level your heights, okay, according to a reference point, okay, or rather a reference surface. So the 5 points within each cell, you may consider as your triangulation points. And this we use to level the data to the present, let's say, analytical sort of surface. Okay, and it can be done provided, this is the condition, that the samples that are in the, let's say, detail soil surface. For example, we had Alaska there. We have a close by reference, the GTN analysis. If they are very close, we see that there is a very good correlation. If they are at a larger distance, of course, this is impossible. So the closest the old samples are to the new samples, you get a very nice sort of correlation. And there are examples in the manual showing you how to do this in order to level the data, the old data, to the new data. Let's say use it as a datum in a sense. Am I clear?
I still would kind of like some clarity in how you would take some 1980s data and still make that usable within the current framework.
Well, it can be done. Just a minute. If you, I mean, we don't, now if I go, just a minute.
whilst Alecos is doing that, Keith, I'm guessing that you've got a fair amount of data still from when you were up in Alaska.
Well,
a fair bit, yes, but the US Geological Survey was attempting to improve the geochemical mapping of the state, and
unfortunately, they did not succeed.
Well, I don't know about that. I mean,
You can still see the boundaries even in the 2020 version, and this was really unfortunate.
well, I think the issue is that if your detection limits are very high, then where you have a non-detect, you have to map that at the detection limit. So that gives you an artificially high baseline.
Yes, this is a problem, of course. Just a minute, if I can get chapter 2. No, it can be done.
Yeah, I believe the USGS was looking to reanalyze a lot of the samples that they had in their
Well, that's
repository.
Yeah, this is the best way to do it.
Yeah.
All right. Can I share a screen again?
It's not coming through yet.
Just a minute.
That's okay.
Just a minute. Where is my screen now?
That's coming up.
Now there is one chapter showing you how for example, here we have used the nickel concentrations.
Hold on a second, because I think you might not have given us the screen you wanted to.
Can you see my screen?
I can see your screen, but what actually I'm seeing is there are 3 possible things. One is SEGH images, then Demetriades et al. And Zhangdong Lai. So those
just
are.
a minute. I shut off that one.
I thought that wasn't what you were trying to use.
Now, this, can you see this one? It's a table.
Not yet.
Can you see the table?
No.
No. Let's try it again.
Still got the same.
Just a minute. Try again.
I've seen your hand, Xiaosheng. We'll come to you when we've ironed this one out.
Yeah, no problem.
Well, this is the problem with distant. Share screen. Right, sec manual. Why do I have so many screens? I can share. Share this one. Can you see it? Now there are.
Yes. Okay. Thank you.
Right. So here is the nickel data that we have from an old survey carried out in Norway, very detailed. And here are the results. And here are the GTN results, the Global Terrestrial Network results. Okay. And as you can see, we have re-estimated the results because we had a very nice correlation. Okay. Here we have the plots. Oops, sorry. You see, the correlation is really good. Now, the key is that you have to have, as I said earlier, results that are very close to the global terrestrial network. And here we have another, I go to another example. Now this is the, oops, sorry, jumped to 3. Oh, sorry. Oh no, something wrong here. It's missing. Now this is how it's done. Now this is the leveling done by a team. Okay. And this is the way the surveyors use for leveling. So the results of the global terrestrial network are used as the datum. Okay. And you have the results of your old survey, and you try to level them using triangulation. Okay. So the procedure is explained in this chapter. I cannot have to, we need another hour to explain it, but it is there, it's explained, and you can download everything from the website in order to test it, if you have the data. And also the data, our data set is there, so you can actually try it. Okay.
Keith, does that answer your question, or does it move you forward?
Yeah, I think we've moved forward. Yes.
That was actually
Anyway,
relatively.
you can try it and let me know.
My question on the back of that one was, it was going to be to Keith to say, who's going to do that then?
Well, everything is explained. You know, just somebody that just has to sort of sit down. There are exercise data sets, you may say, that you can use. And if you get the same result, then you are there. If you are wrong, then you just send us a message and we'll tell you where you went wrong.
I think the thing that strikes me looking at that is very much the fact that, you know, sort of maybe 40 years ago, it would have really not been possible to do a lot of what is in there, because we've moved forwards a very long way, not so much with the ability to sample and to understand it, but the ability to put most of this stuff into a computer and work fairly quickly. And I think that's the thing that's made the difference there.
Well, I think it is something, Gillian, that especially for long-running programs, you have to have a very good quality control. This has been shown by the British Geological Survey's regional geochemical mapping. Now, if they did not have this very good quality control from the beginning, they would have not been able to level the data. Okay, they level the data. There is a chapter there again, using examples from the British Geological sort of experience, and is really good. So, you know, when there is a long-running project, you must have standards inserted all the way from the beginning to the end, the same standards, in order to be able to level the data. Because, as you say, I mean, analytical methods change, detection limits change, and so you need to cope with all these things. So you have to have a very good quality control system installed from the beginning.
Yeah, thank you. Xiaosheng.
Okay, thank you. Just now we're talking about historical data. So I'm thinking of the spatial aspect, because you are trying to produce the global geochemical, you know, data. Obviously, you get different countries here. And then you are also talking about the samples should be prepared in the same laboratory. So I just wonder how you coordinate these different countries and how can you get the same laboratory? Thank you.
Well, this is a problem, but we have managed to solve it in Europe. We had, as you know, two sort of pan-European projects. One, the Forex Geochemical Atlas, which used the global terrestrial network, where there were 26 countries involved. And then the GEMAS project for agriculture and grazing and soil, where we have 33 countries involved. And we agreed that all the samples will be prepared in a central laboratory, and that we selected the Slovak laboratory. And also, of course, we had the standards made already in the same laboratory. Okay. So we have managed to do it, and that's why we say is at present these are the only harmonized geochemical data sets that exist in the world at present. And because we have, first of all the samples again were analyzed in the same laboratories. Okay, so everything was standardized. And you know, for the global terrestrial network, because this is going to be used as a datum. Okay, so you know, a datum must have very strict standards. Otherwise, you will not be able to level the data of more detailed and, let's say, old geochemical data sets that exist all over the world. Okay. But if the project goes ahead and follows precisely the instructions, at some stage in the future, we'll be able to have a much more detailed geochemical map of geochemical maps of the whole world.
Thank you.
Thank you for that. I'm not seeing any other hands up. Does that mean that all the information has been imparted perfectly? Do feel free to ask questions. So whilst we give that one a moment to come through, I'm going to backtrack onto something that you said right at the very beginning. And there may well be some people on the call who are at the early stages of their career. And you were talking very much about necessarily starting with PhD until quite a lot later, or these days to go in at a very early age and make sure that you've got it. I actually would add on that it's very important to know what you want to do and why you want to do it, because if you're wanting to go into academia, then absolutely and completely you're going to need your PhD. But I'm suspecting that there may well be people who are on this call who are, from a business perspective, looking at why the network is there, for whom the PhD isn't necessary, and it's getting to a, as you quite rightly pointed out, I'm going to stick my hand up at this point, it's about that chartership rather than the PhD. It depends entirely upon where you want to be. And if you split the geological profession out, you've got people who are out there in the wide world with their shovels and spades and sampling stuff, and you've got people who are sitting back in the universities analysing things in a rather more detailed way. So I think the point that you make about wanting to know what you need to do before you decide you're going to go down one route or the other is one which is really good to consider.
Yes, I agree with you, Gillian. It's very important to decide that what sort of career you're going to follow. And if you are going to be, let's say, a professional and you are interested in an academic career, you must certainly sort of go after chartership, because these are professional titles. Okay, and they are more respected, and says, you know, a PhD is a stationary sort of thing. You have done it and you finished. If you do not follow it afterwards, and you do not you are not up to date, your PhD really is dead. You know, so, but with chartership, you have to prove yourself every year.
Yeah.
You know, so in my opinion, a professional must have a chartership nowadays.
I would agree with you completely. Thank you for that. Are there? So I know it's 5 o'clock. So for those of us who are on UK time, it's the end of a working day and the end of a working week, and you might actually be quite keen to get away. I'm actually looking. I'm impressed by the person who is on the Martin Gillespie shot there with the wine bottles behind you, obviously getting ready for a weekend wind down. So if there are no further questions, I'll let people get away to whatever they want to do for the weekend, with a very big thank you to Alecos. It'll have to be a virtual clap, I'm afraid, because we can't do that over here. But thank you again very much indeed for providing with us a lot of information. And everybody else, take care. And I should also say a huge thank you to our controls in the background for keeping the Zoom going for us as well. So thank you, Olivier.
Yeah, thank you, Olivier. Okay, have a good weekend, everybody.
Okay. Bye, everybody.